Okay, Algebra 2, this is another day of review. In this section, we're going to go over just the discriminant. Um, a lot of you guys probably forgot what that was even talking about, but we do talk about this quite frequently in other math classes, so we're going to go over this again. In the next video, we're going to do the quadratic formula, but the discriminant kind of comes from the quadratic formula. Okay, so I'm going to talk about him for just a second. We won't go into the entire formula, but the quadratic formula was that song that I played for you, so that can help you remember what the quadratic formula was. But the quadratic formula you use when you cannot factor. Okay, so when you can't factor, but you're still trying to find the zeros. Use to find zeros, or the x-intercepts of a function. Okay, so that's what I'm doing when I'm using the quadratic formula. Okay, now I said in the last video that when you are looking for those x-intercepts, or when you're looking for those zeros, you could have three different types of things happen. Okay, you could have two solutions happen. Okay, so you have this type of thing going on there where you have crossing at two places. So this is two real roots, or two solutions. Okay, you could have it come down and touch and go back up, so it only has one solution. So one real root, one solution. And then you could have a parabola that's doing one of these, or maybe it's above, where it's not touching that x-axis at all, which means you have no solutions, okay, which I a lot of times write like that. So they sometimes will call them two imaginary roots, and we'll talk about that here in just a second, but you're going to end up with an I in your solution, or I just write no real solutions. So you have two solutions, one solution, no solutions, okay? Now, in the quadratic formula, this little piece, this b squared minus 4ac is embedded, okay? So that little piece right there, and that is the discriminant, okay? So up here at the top, the discriminant can be determined by that b squared minus 4ac. That's what this guy is, okay? Now, the discriminant does not include the square root. It's just b squared minus 4ac. That's it, okay? We can get rid of the square root. We just need the stuff that's underneath, okay? So, and this tells me what my solutions will look like, whether I'm going to have one solution, whether I'm going to have two solutions, or no solution, okay? Now, let's talk about what a, b, and c are to start with, okay? So in my function, I will usually have an x squared, let's do plus something x plus something, okay? So I'll have pieces out in front of here, okay? And I'll have y equals that, okay? A, b, and c will be those numbers that are in front of x squared, x, and then the last digit is going to be your value of c, okay? So that's where those values are going to come from. All right, when you're calculating a discriminant, if I think about the quadratic formula, and I have negative b, let's use the scenario. Let's say that I end up, when I do my quadratic formula, I'll end up with negative 4 plus and minus the square root of 0 all over 2. Let's say that that's what I end up with for my discriminant, okay, or my quadratic formula, the entire quadratic formula. Okay, when this is the case, the b squared minus 4ac would end up being 0, like in this scenario, okay? Looking at this, I can see that negative 4 plus the square root of 0, the square root of 0 is just 0, right? Negative 4 plus 0 divided by 2 is the same thing as negative 4 minus 0 divided by 2, right? So I only end up with one answer, okay? Because adding 0 and subtracting 0 are going to give me the same solution. And that's where I get only one answer from, okay? Now let's say instead that I get negative 4 plus minus the square root of 4 divided by 2. Okay, so I get this number in here, and my discriminant in that case is the number 4. Okay, this number, b squared minus 4ac, is a positive number. Okay, it's the positive number 4. Okay, thinking about the square root of 4, the square root of 4 is 2. So what I can see is that if I take negative 4 plus 2, okay, negative 4 plus 2 is negative 2 divided by 2, that will give me negative 1, and negative 4 minus 2 is negative 6. divided by 2, which is negative 3. Okay, so when that number is a positive number, I'm going to end up with 2 answers, 2 solutions. Okay, so when your discriminant or whatever is underneath of there, when it's positive, 2 solutions. Okay, now let's talk about it being a negative number. So let's say I have negative 4 plus minus the square root of negative 4 divided by 2. Okay, the square root of a negative 4 is kind of like, I'll write it in purple. This is kind of like the square root of 4i, or really 2i in this case, because the square root of 4 is 2. So I have an imaginary answer, but you can't take the square root of a negative number. That's why we write it as an imaginary number. So basically the 0 doesn't exist. So he's not touching the x-axis, so he doesn't have a 0. So there's going to be no solutions here, or no answers to this equation here. And that is because this b squared minus 4ac, this negative 4, was less than 0, or it was a negative number. Okay, so that discriminant can tell me when it's embedded inside of the quadratic formula, I can just refer to this number here that we've circled, that discriminant number, and it will tell me everything that I need to know about what that graph looks like. Well, I guess in reference to zeros. Okay, so let's look at each one of these, and we're not going to calculate the entire quadratic formula like I wrote out over here. And these were just examples. I wasn't pulling these from anywhere. But we're not going to calculate the whole quadratic formula. We're just going to do b squared minus 4ac. Okay, so the one thing that you want to make sure that you have set up beforehand is I want to make sure that all of my pieces are on the same side of the equal sign. Okay, so like number 2, this 72, he's going to have to get bumped somewhere. Okay, we'll bump him over. But as far as 1 and 3 go, those solutions, or those equations are going to be ready to go for me. Okay. If it helps, write out what a, b, and c are in each one of these cases. Okay, so a is the number in front of x squared, which is 1. So I'm going to put a 1 there. B is going to be negative 3. Make sure that negative goes with it. And c is going to be negative 5. Make sure the negative goes with it. Okay, so then all I have to do is b squared minus 4ac. It's all the stuff that's underneath of that radical symbol. I just want to know what this number is. If it's a negative number, if it's a positive number, if it's 0. Okay, and that will tell me how many solutions I have. All right, so I'm going to start by plugging b in. Negative 3 squared minus 4 times a is 1 and c is negative 5. Okay, so let's try to do some of this in our head. Negative 3 squared is going to give me 9. Okay, negative 4 times 1 times negative 5. Okay, there's 2 negatives in there, which is going to make a positive. Okay, and then 4 times 1 times 5 is going to be 20. So 90 plus 20 is 29, and this is a positive number. Okay, so this is going to tell me how many solutions I have. Since it's a positive number, I'm going to end up with 2 solutions. Okay, because I have plus that number and minus that number. So plus the number minus the number is going to give me 2 answers, like it did here with negative 1 and negative 3. So this will be 2 solutions. Okay, and I abbreviate solutions as SOLNS. You can do that too if you want. Okay, so there is the first one. All right, let's go to number 2. I'm going to write out A, B, C. As you go through these and do these more and more, you don't necessarily have to write out A, B, and C, but it just helps me. So A is 2, B is negative 24. Oh shoot, we haven't moved it yet. I have to move this 72 onto this side. So how do I get that 72 to move over there? Well, to get him away from here, I'm going to add 72. It's already a negative 72, so I need to add 72. So it will be end up equal to 0, right? 0 will be left on the right side. And then I'll have 2x squared minus 24x plus 72 is what he will look like. Okay, now don't try to add the 24x and the 72 together because the 72 doesn't have an x on the end of it. We just have those 3 pieces, okay? And so, you know, my A is still 2, my B is still negative 24, my C now is going to be 72. Okay, this one we might not be able to use or just do in our head because they're kind of big numbers, okay? So let's do B squared minus 4AC, and we're going to plug those numbers in, okay? B is negative 24 squared minus 4 times A is 2 and C is 72. Okay. All right, 24 squared, negative 24 squared. All right. Now, whenever you're squaring something, you want to make sure that that turns to a positive. Okay, so what you can do is if I type in negative 24, let's do this. If I type in negative 24 squared, just like that, it's going to give me a negative number. So what I either have to do is negative 24 close parentheses squared like this, then it will give me a positive number. Or if I just know and remember that this negative is going to turn to a positive when I square it, I might as well just type in 24 squared because I know that negative is going to go away. I don't necessarily need to type that in because that's extra stuff for me to type. So 576 is what my 24 squared is going to be. Okay, negative 4 times 2 times 72. There's only one negative in there, so it's going to stay as a negative number. Okay, so I'm not going to put the negative on the 4. I'm just going to do 4 times 2 times 72, just like that. Okay, because I know that number is going to be negative, and it's going to be negative 576. Oh, 576 minus 576 is 0. Okay, how many solutions will there be if I have 0 as my discriminant? 0 is my discriminant, plus 0 and minus 0 are the same thing, so I will only have one answer. There will be one solution if it comes up as 0. So 0 is my discriminant, one solution is how many solutions I get. Okay? All right, last one. I'm guessing this one's going to be no solutions, but we'll check and see. So he is ready to go. He's in the right form, 7, negative 3, and 2. That's my A, B, and C. 7, negative 3, 2. B squared minus 4AC. So B squared is negative 3 squared minus 4 times A is 7. C is 2. Okay, these are fairly small numbers. Let's see if we can do this in our head. So negative 3 squared, that's going to be positive 9. All right. Negative 4 times 7 times 2. There's only one negative in there, so it's going to stay negative. All right, now let's deal with the numbers. 4 times, let's do this. I'm gonna do this so I can deal with smaller numbers. 4 times 2 is 8. Okay, so if I know 4 times 2 is 8, now I can take 8 times 7. Okay, I hope that kind of made sense a little bit. Since that gives me smaller numbers, I would take 4 times 2 first. 8 times 7 is 56. Okay. Now, if you didn't want to do it that way, if you want to multiply it in the order that it's in right now, 4 times 7 is 28. And then I'm going to take that times 2, which is the same thing as 56. Okay, so it doesn't really matter, but in my brain, I want to take the two smaller numbers and multiply those together first, because that makes it easier for my brain to deal with it all at one shot. Okay, so 9 minus 56 is going to be a negative 47, I think. Yeah, negative 47. Doesn't really matter because it's a negative number, so we don't really care anyway. But the discriminant is going to be negative 47. And then because that is a negative, that means I'm going to have no solutions, because negative 47 would end up being inside of the square root for a quadratic function, giving me no solutions or an imaginary solution. So he's not going to touch the x-axis. He will actually be a smiley face that's not touching the x-axis. So he'll look something more along the lines of that. Rather than going downhill, but still no solutions for that. Okay, all right, so that's discriminant. Next video we'll go over quadratic formula, and then we'll move on to the next thing.